Here is the SVD formula. So we can here. So here we know this is the formula. This first is the original data. Uh, so this is m times n is m by n. So we can use the function to decompose it. So we get the three small matrix is m times I, and then times the m by n, and times the n by n. So what is different? Actually, the left one is the left singular vector, and the right one is the right singular vector. The middle one is the singular value. So I'm going to take an experiment to talk about it, and then you will nail them. So here is a experiment. So we know from the original data. So we can say here, here is original data. This is 4 users rated 6 movies. Here this the type of this matrix data is 3 by 4. So we can now here, sorry. So we can from the function. So we can get the 3 small matrix data. So we know the original data is 3 by 4. So we can get the first is the left singular vector. So here is 3 by 6. Sorry, is 6 by 6. So y is 6 by 6. So we can now from here 3 is the moles. So here is 3. Sorry, my fault. It's 6. It's 6. 6 moles here. It's 6 moles here. So it's 6 by 6. So this is means left singular vector about moles, and the right it's similar with the so it's similar with the right. The right singular vector about users. Here is 4 users, 4 by 4, and carrying 4 features is over here. And then this is the important singular value. So y is important, so we can read this. What's the singular value? The singular value is corresponding the value of left and right vector. And then the number of value means how important of the vectors for us. So it means we can say the first 2 numbers is greater than the third and first. So it means the first 2 features is more important than others. So it means the first 2 and about moles, and the first 2 about users is so important for us. So why I'm going to talk about that? So this is a small instance. So here, this is 2 pictures about a beautiful woman. So this where I'm going to get the answer is how this woman looks like. So from these 2 pictures, we can know the answer, but we know the left picture is so clear, and also the number of this data about these pictures is so big than right. But the answer is we just need to know the woman looks like. So we can get the answer from these 2 pictures. So we can also use the right, although it is not clear. But you have to know, like when we process some data, when we use a recommendation system, we just need to get the answer fastly. And sorry, it's fast. It's okay for us. And then, so it means we can just get the first 2 features is necessary for us. Why? So we can know this function. This function is about we can say here. We can now the original function is 6 by 6 times 4 by 6 and time 4 by 4. From this function is also a familiar function about SVD. So we can here. So it's also 3 by 2. Sorry, it's 6 by 2 times 2 by 2 times 2 by 4. We can get the final function. The formula is 3 by 4. So it means we also get the 3 by 4 original data. So it's same with here. It means it's actually what are the difference with the original one? It's just the same with the picture. Is the difference the the difference is the actually the if they are you, if uh, if they are clear, I think. So it means we just need to guess the first two, and then it means 6 by 2 times 2 by 2 get 2 by 4 matrix. Then we can get the final one. So why I'm going to talk about this? Actually, so you can see here. So here this is some information about the users. So this is the first two features about the users. So here, so it means we can just use them. We don't need to use the others. So here, we need to get the similarity for each users. But how do we get that? So we can convert them into the two-dimensional coordinate. Here, so we can the future zero is just the value of x. The x is, we can say the value is negative 0.6, so it's over here. The y is 0.5, so it's over here. It's user A. So it's same with user B, C, and D. So the user B is over here. But how do we get the similarity? Okay, that is the function, cosine function. So we just put the value of x and y into the function, and so we can calculate the similarity. So the similarity is the value of cosine. So so if the value of cosine is big, so it means they are so close about user A and user and B. So so right now